Hello everyone, welcome back. So recently I have developed an app that analyzes medical reports backed by a RAG knowledge base. And in that video, I had claimed that I have created this RAG knowledge base free of cost. And some of you asked me to create a tutorial of that. So in this video, I'm going to show you how I did that. This video is appropriately timestamped, so feel free to skip ahead. Now, what is a RAG? A RAG is a Retrieval Augmented Generation method specific to a knowledge base. So for our case, we want our LLM to be knowledgeable about medical studies before it can answer questions about medical report. But isn't that the use case of fine tuning? Well, as opposed to fine tuning, where we create our own version of tuned LLM by feeding this information in a structured way beforehand, RAG allows us to use any generic LLM while allowing us to determine the relevant information for the user query ourselves using similarity search and stuffing those information in the prompt at the time of generation itself. Not only we don't have to do the data wrangling steps required for fine tuning, which means we can update knowledge base much more quickly. Also, it allows us to see the exact source snippets used in the generation, making the generation process arguably much more transparent. Now, in my example, I'm going to use a popular medical diagnosis book to push into our knowledge base, since this app is going to be used to make sense of diagnostic reports like blood CVC, lipid profile tests, etc. Obviously, you can increase the knowledge base as and when you'll be pushing more and more books, articles, and research papers inside the knowledge base. So with that, let's have a quick demo and then we'll start building. So here is a quick demo of the app. As you can see, I have selected 2 PDF files to be pushed into the Pinecone database, and I have also mentioned the index name under the Pinecone database as medic, and the namespace just a test namespace. That means when I'll be clicking this update button, this is going to first create chunks of this PDF file, and then all those chunks will be pushed one after the other into this namespace under the index name called medic into the Pinecone database. So what is going to work is that I've chosen this embedding model in my case, but you are free to choose any other embedding model of your choice. So this embedding model will be pulled into our browser environment. It will create a local instance of it, and that instance will be creating all these embeddings for all these chunks of the PDF file. I am not choosing any quantized version of it, as I expect it to run for hours. For example, for huge medical books, it usually took me about 3 or 4 hours. So I let it sit there and run overnight, and then at the end of the night, I saw that okay, all the embeddings have been pushed to the Pinecone database. So it makes sense to use the full-sized model in this case. So I'm using the Onyx version since it will be pulled into our browser environment and it will spin up a local instance. And I'm not using any quantized version of the model. I'm just going to pull the whole 1.34 GB full-sized model into our browser environment. And that model will be creating embeddings for all these chunks for the first PDF file. And then it will push all of them into the Pinecone database. And then again, it will iterate over all the PDF files or any text file that I choose to push to the Pinecone database. So now let me go ahead and click on this update button, and you can see it shows the progress bar. So first it is pulling the 1.34 GB model, then it will start creating the embeddings, and then it will start pushing into the Pinecone database, and you will be able to see that a new test namespace has been created here. So this is the first one I have created earlier, but it will create another namespace under this, and we'll be able to see that it is pushing. So as you can see, it is pushing into the namespace test 10 embeddings at a time. So that means our model has been, a local model has been spun up, and then all the chunks. So you can see for the first PDF file, it's a small test file. We have created around 436 chunks, and 10 chunks at a time are being pushed into the Pinecone database, as you can see here. And after the first PDF file is done, it will iterate over the next PDF file. So our first PDF file is almost pushed. So as you can see, 436 chunks should have been pushed, and 420 has been pushed. So after this 436 chunks has been pushed for the first file, it will pick up the second file, and then it will do the same creation of embeddings and pushing to the Pinecone database for the second file as well. So as you can see, the first file is done, and for the second file, it is a much larger file, and this is going to take a lot of time. So for my case, when I first pushed it to the Pinecone database, it took overnight. I'm just going to just stop the process since this is just for demo I'm showing. So now let's go to the video where I show you how I build this from scratch. So we'll start by creating a folder on our desktop called Mediscan Pro. we will open a terminal window on the folder, then write code dot so that it opens it up in VS Code. Then I will hit Command J to open up the terminal and then create a next tab by the command npx create next tab @latest dot, so that it creates it within this specified directory and it does not ask for a project name. I'll use the defaults here. You can check the defaults that I have used. I'm going to use the TypeScript so that most of my errors are caught as and when I write the code and they don't pop up in the runtime. After that command executes, it is going to populate our directory with some skeleton code for Next.js app. Before I run the app, I'm quickly going to install Shadcn UI. This is one of the most popular UI libraries at this moment for Next.js apps. I'm going to use a multitude of UI components like buttons, text fields, accordions, etc. And Shadcn is going to make it very easy to install and customize them. Since installing each one of those components in Shadcn essentially copies them over to our own project directory, so we have total control over the look and feel of the components on our page. So I'll write npx Shadcn UI @latest in it. I'm going to select the default theme here. You can check out their documentation about the differences between the default and New York theme. There are slight differences in terms of the icon packs and some elements look and feel, but I'm going to use the default here. For the base color, I'm going to again use the default slate. For CSS variables, I'll choose yes. Now I'll go to the page.tsx file under the app directory, which is the landing page for our app. Here I'll get rid of all the JSX code within the main tag. I'll delete the justify between class as well. Here I'll write users landing page and save it. Now to see if everything is working, I'll bring up the Next.js app by writing npm run dev and it will spin up the service on localhost 3000. If I command click on it, it is going to open it up in the default browser and we can see that our app is running. So now, as we said, it will have two parts. In the first part, we'll create the knowledge base by uploading PDFs and texts to our vector database. So I will create a page called Pinecone in our Next.js app because as you can tell, we are going to use the Pinecone as our vector database. I'll right click on our app directory and create a new file. Here I'll type pinecone/page.tsx. That way it will create a directory named Pinecone and inside it, it will create a page.tsx file. Inside it, I'll use the ES7 plus code snippet for creating a component tsrafce and hit tab. It will give me the skeleton for a Next.js component. As you can see, if I start typing, then I can rename the component. I will give it a name vector.db page. When I'm done typing, I can hit escape and my skeleton code will be ready. If you cannot use the tsrafce snippet, then you can go ahead and install the ES7 plus extension. You can hit Command Shift X and open the extensions sidebar. Here you can search for ES7 plus and it will be the most downloaded one at the top. After I save the component, I'll move over to the browser localhost 3000/pinecone and we can see our page is available. Now back in the code for this page, I'm going to delete the div and use the semantic tag rather main. I'll give it some Tailwind classes for styling, flex column, item center so that the items are placed in the center of the page. Also, I'm going to give it a padding of 24. Now we'll install a few Shadcn components. As we said, we'll install them all in one single command. So I'm going to write npx Shadcn UI @latest, add button, card, input, text area, label, and progress. Progress installs the progress bar, which we will be using to show the uploading progress. Inside the main tag, we'll create a card element. Make sure that you import the components from the components/UI directory where Shadcn places the code for these components when we install them. Within this, there will be a card header and a card content. So here is a sketch of the page elements. We will have a card title at the top and card description within the header. And as part of the card content, we will have a grid where on the left side there will be a field that shows the name of the files to be uploaded as well as the index name and the namespace within that index. When we'll create a Pinecone database instance, we will also create an index and we'll match that name here. It will be clear when I show you in the Pinecone website when we create that index and the instance of the vector database. Under the grid, we'll place a progress bar that will show how much of the file has been pushed to the vector database. So in this card header, we'll write card title. The text will be update knowledge base. In the card description, I'm going to write add new documents to your vector.db. In the card content, we will create a div, give it a class name grid, grid calls 3, We'll mention 3 columns here as we will make the left element span over 2 columns. We will add a gap 4 within the elements. As the first element within the grid, we'll create a div and give it a class name called span2 as we said, and make it a grid in itself so that we can place text area for file list and index name and namespace within this div itself. And we'll want to have a gap 4 among those elements. I'll also give it a border rounded large and a padding of 6. I'll add the second column, which will be placed as the third column in our case. It will be a large button, which will allow us to start the uploading process. And I'll import it from the component/ui directory, the button component that we installed. I'll give it a variant of outline, which is one of the out-of-the-box variants from Shadcn. We'll give the button a class name of width full and height full. Inside the button, we'll add a database icon that comes from Lucid React. It got installed as part of the Shadcn's icon pack. We'll give it a size of 50. We'll save it and run our app using npm run dev. If we refresh our page now, we have the framework ready. Now let's go ahead and add the text fields in here. So inside the container, we will have a text area for displaying the list of the files. We will also add a button for refreshing the file list. Inside the button, I will use refresh counterclockwise icon from Lucid React. We'll set the container as relative and the button as absolute and place it using the right and top properties. We'll set the variant of the button as ghost so that it does not have any outline or background. The size of the button, we're going to set it as icon. Then I'll create the text area. I'll make it read only because it will only display the files to be uploaded. I'll give it some styling, minimum height 24, resize none. I'll give it a border, padding of 3, shadow none. And when it's disabled, I want the default cursor to be shown and focus visible, ring 0. That is going to make sure that whenever we click on this and if we are reading and scrolling and if it is in focus, we don't want any ring to be shown. That looks really ugly in my opinion. And I'm going to use text small and text muted foreground. Text muted foreground is a class name that does not come from Tailwind. It got added when we installed Shadcn UI. Above that, I'll show a label with the text that says files list. Now let's add a container below this. This will contain 2 inputs, one for the index name, another for the namespace. I'll create a div with class grid columns 2, gap 4. In here, there will be 2 divs, each with class grid, gap 2. Each of these elements will have a label. For the first one, it will say index name and an input element with placeholder index name. Similarly, I'll create a grid for namespace, and here the label will be namespace and the placeholder will be namespace. Now when we're updating the database, these fields are best kept disabled. So we'll first create a state variable. I'm going to write state snippet and hit tab. I'll name it is uploading with initial value as false. And in the input tag, I'll simply write disabled is equal to is uploading. I'll also add a styling. That is, when disabled, the cursor should not change. It should show the default cursor itself. So disabled : cursor default. I'll do the same for the namespace input as well. On the same line, we want to disable the upload button as well. I'll add the same disabled is equal to is uploading in the upload button as well. Also, I'll change the button a bit. I'll add a move up icon beside the database icon just to show that it is uploading. So for that, I'm going to just quickly wrap this icon in a span. Give it a class flex and flex row so that the up icon is placed to the right of the database icon. Here I'll write move up icon from Lucid React, and I'll give both of these a color, stroke within square brackets. I can specify the hex code of the color, and I'm going to use a specific shade of red. Now below this grid, I'll add a container for the progress bar and the file name. I'll give it a margin top of 4. So here there will be a label with text file name. I'll add another div which will basically contain a progress bar and a small animated loader icon. So I'll give it a class name flex row, item center and gap 4. Inside it, I'll add the progress element from component/ui directory. I will add a placeholder value of 80 for now, which we will later change based on the actual progress. And I'll add a small spinning animation. So for that, I will use Lucid Loader 2 icon from Lucid React, and I'll give it a class name stroke. Within square brackets, I'm going to use the same red shed that we used, and animated spin, which will give it a rotating animation. Now finally, we will conditionally show the progress bar container when it is uploading only. So we'll place this container inside curly braces, and in front we will add is uploading ampersand. That way, only when it is uploading, this whole JSX part is going to show up. Now if we go ahead and set the is uploading to false, the progress bar vanishes and it will only show when it is uploading into the database. So in this video, we'll continue building our RAG application. We are building it in two parts. In the first part, we are creating an app to insert the documents like PDF and text to Pinecone database that is going to create the knowledge base for us. We have already created UI for this app, and as the next step, we are going to add functionality to our app. So in the UI code, we have specified that this button will be used to start the uploading process. So we'll start by creating an on-click handler on this. I'm going to write on start upload, and I'm going to create this function on top here. Const on start upload is going to be an async arrow function. It won't take any parameters. I'll also create two state variables up on top for the index name and the namespace. So I'm going to write state snippet index name, and I'm going to initialize them with empty string. I'm going to do the same for namespace, and I'm going to bind these state variables with their respective input fields. So for the index name, I'm going to say value is equal to index name, and on change, which gets an event, I'm going to use the set index name function e.target.value to set the index name. And I'm going to do the same thing for the namespace input as well. So I'm going to write value namespace, and on change, which gets an event, I'm going to set the set namespace e.target.value. So that way I'm doing two-way binding with the state variables. Now inside the onStart upload function, I'm going to send a fetch API request. So I'm going to write const response is equal to await fetch, and I'm going to mention the API slash update database. I haven't created this API yet. I'm going to create it in a while, and the method is going to be post, and as body, I'm going to use JSON stringify and pass an object that contains the index name and the namespace. Now I will console log the response here, and we will create a function that is going to take this response and unpack the streamed progress that we'll be receiving as part of this response. So I'm going to create a function for that, await process streamed progress, and we are going to just send the response into it. For now, I'm going to comment it out because I'm not going to create this client-side inference at this moment. I'll just go ahead and create this API first, and then we'll come back to this client-side code. So for that, I'm going to right-click on the root of my project and click new file, pages/API/update database.ts. That is going to create a pages directory, inside that API directory, and inside that update database.ts file. This folder structure is going to make sure that API with this path gets created. So if our Next.js application is running on localhost 3000, that means this API will be available on localhost 3000/API/update database.ts. Inside this, we'll write a handler function. So we'll write export default, and it's going to be an async arrow function. As parameter is going to take the request instance of type next API request, which gets auto imported from next. Also, it is going to take a response instance, which is going to be of type next API response. This response instance will allow us to write regular progress updates back to the client. So here I'll check if the request is a post request. So I'm going to use the request.method is equal to post. If that is the case, then I'm going to unpack the request body. So I'm going to say request.body and parse that as a JSON object. So I'm going to say JSON.parse. And in the same line, I'm going to unpack the index name and the namespace that we sent as part of the request body. Now I'll go ahead and create another function, await handle upload, and we are going to pass the index name, the namespace, and the response instance here. We will pass the response instance because we want to write regular updates onto the response. So I'm going to place my cursor here and then hit command dot, and it's going to allow us to write the function. And I'm going to change the type of the index name. It is going to be of type string. The namespace is also going to be of type string. So inside this function, we will use LangChain to load the documents. So first, let me go ahead and install LangChain. So I'm going to stop the service by Ctrl+C and then npm install LangChain. Installation process takes some time, so I'm going to come back when this is done. So after that is done, we'll be able to use the directory loader. So I'm going to write const loader is equal to new directory loader, and that is going to be imported from LangChain document loaders. And as the first argument, we'll have to specify the path of the document, and I'm going to create a documents directory. So at the root of my project, I'm going to create a new folder called documents, and here we will be placing the documents like PDF or text that is going to go into the knowledge base. So that is the documents directory we are specifying as first argument. And as second argument, it takes an object that basically will be a key value pair that will mention the type of the files. So for example, for PDF, and as the value, it is going to take the loader that is to be used to load that specific type of file. So that is going to be an arrow function that takes a path as a string, and it should return a new loader. For PDF, we are going to use PDF loader, and again that is going to be imported from LangChain document loaders, and it is going to just take the path. Actually, I should have placed a semicolon there because it's a key value pair. And I'm going to do the same thing for text loader. So for text, I'm going to write dot text, and it is going to be a text loader again from document loaders of LangChain. Now for the PDF loader, just using the PDF loader from LangChain is not sufficient, as you will get runtime errors. And in their documentation, they mention that you'll have to install another package called PDF parse. So I'm going to go ahead and install that, npm install PDF parse, and that is going to allow us to load the PDF successfully. Now, one thing for the PDF loader is that by default, it considers each page in the PDF document as separate documents. So in this case, I want to load the whole PDF document as one single document and then split the document only when I need to create chunks for embedding. So for this PDF loader, I'm going to pass another object to pass an option split pages to false. That is going to load the whole PDF document as one single file. After that, I'm just going to go ahead and call the load function. So I'm going to write const docs is equal to await loader dot load, and that is going to give us the documents in a JavaScript array form. And since it's an async function, I'll have to make the parent function async as well. So the long running bad job of chunking these documents and creating vector embeddings and then uploading them onto Pinecone, all those I'm going to do in a separate utility class where I want to pass these loaded documents and a Pinecone instance, and it will run those processes in the background and give us progress updates by calling a callback function. So I'll create an instance of a Pinecone client here, but before that, let me take you to the Pinecone website. So here you can log in using either GitHub or Google. I'm going to use GitHub. So when you load for the first time, you will see an empty dashboard. You will not have any indexes. On the starter plan, you can create only one index, but that's fine, as you can partition that one index using namespaces, which will allow you to create multiple knowledge bases within one index. So I'm going to go ahead and create index. I'm going to name it index 1 because I don't know what all knowledge bases I'm going to create within this one index. Now for the dimension, it has to match the dimension of the embeddings you will push into it, and that will depend on the embeddings model that you are going to use. I'm going to use the MixedBread AI model. Let me show you the Hugging Face page of this model first. So I'm going to go to the Hugging Face and I'll go to the model section. On the left side, I'm going to select feature extraction, which is basically embedding generation in Hugging Face terms. And I'm going to use this topmost trending model at this moment. Now, when you are creating embeddings for huge amounts of texts, for example, from a medical textbook, then we are talking about thousands of chunks, and that means thousands of embeddings will have to be created. So I wanted that I fetch this model onto my own device and run these thousands of chunks through it to generate these embeddings. Because if I were to use OpenAI's GPT or any API based options, then it would come at an additional cost or rate limit for free tier. Also, I would have to build a mechanism to resume the embedding creation if for some reason the connection is disrupted. As while testing for this video, I found that the textbook that I'm going to use took about 4 hours to be pushed to the vector database. So here, if I click on this model, I can see that it supports Transformers.js library, which is awesome because this will allow us to fetch this model onto our own device and generate these thousands of embeddings for free. Now, I didn't find the dimension for this model on this model card itself, but if I go to their website and go to docs, so this is the model I'm going to use. So as you can see, it says that the dimension is 1024. So that is the dimension I'm going to use, 1024. And for the metric, I'm going to use cosine. As for textual similarity, cosine is recommended. The other options in free tier, I cannot change. So I'm going to go ahead just and create index. Now I'll go to the API keys section and create a API key. I'm going to give it a name key1 and copy the API key here. And at the root of my project, I'm going to right click and create new file .env. Here I'm going to save it with the key Pinecone API key. This key can be anything, but we're going to paste the API key that we copied. And please use your own API key as I might delete this API key before publishing this video. As best practice, whenever we add a .env file, we add it to the gitignore file as well, so that this gets excluded when we push this repository to GitHub. So after that is done, I'm going to go ahead to the API, and first we'll have to install the npm package for Pinecone. So I'm going to write npm install @pinecone database/pinecone. With that, we'll be able to create a Pinecone instance. So I'm going to write const client is equal to new Pinecone. It is going to be imported from the package that we just installed, and it takes only one parameter, which is the API key. Earlier they required the environment to be passed here as well, but in the new documentation they don't require that, and we are going to use the same key that we saved it with in the .env file. And here, just to satisfy TypeScript, I'm going to use the assertion operator, that is telling TypeScript that this key and value is going to exist in the runtime because we placed it there. Now I'll go ahead and create a utility class at the root of my project. I'm going to create new file utils.ts, and here I will export a function called update vector db. So export async function update vector db, and it is going to take a few parameters. The first one is going to be the client, which is going to be of type Pinecone. It is going to take the index name, which is going to be of type string, the namespace, which is going to be of type string, docs array, which will be basically chunkified and then pushed to the vector database. So it will be a documents array. Now this document is actually coming from web API, but this is not the document that we are talking about. So we'll have to import the LangChain document because we use the directory loader from LangChain. So I'm going to import document from LangChain/document. That way this is going to be of right type. It's also going to take a progress callback, which will be invoked regularly to send back progress updates. So I'm going to write progress callback, and this is going to be a function pointer, which is going to be of a specific type, and the type is going to be just specified by the parameters that it is going to be called with. So it is going to be called with a file name for which the progress will be posted. So this file name is going to be of type string. It is also going to call with total chunks, which is going to be of type number, chunks upserted, which is going to be of type number, and is complete, which is going to be a type boolean. So the idea is that this function, whenever we invoke this progress callback function inside this update vector db function, we are going to specify the file name, the total chunks for that file name that will be uploaded to the vector database, and how many of those chunks have been uploaded, and whether or not we have completed the processing of all the files, and is going to return a void. So that is going to be the type of the progress callback function. Now let's go ahead and call this update vector db function from the API. So right after the creation of the client, I'm going to write await update vector db, and I'm going to import it from utils where we just defined it. And first we'll pass the client, the index name, the namespace, the docs, and a progress callback, which will receive a file name as we specified in the definition. It will receive total chunks, chunks upserted, and is complete. And when this function is called, we are just going to check if the process is not complete. Then we are just going to write the progress to the response using this response.write function. And we are going to use JSON stringify here simply to write back all these values that we received. That is file name, total chunks, chunks upserted, and is complete. And if the response is complete, then we are simply going to close the response by writing response.end. Quick note here, writing a JSON object like this, file name, comma, total chunks, actually means that we are specifying the key value pairs like this, where the name of the key and the value shares the same variable name. So that is why we can use the shortcut of writing this as a JSON object. Now, as I said, that we'll be using the Transformers.js library to fetch these models onto our node runtime. So let me go to the Transformers.js documentation first. So on Hugging Face, I'm going to go to docs and then Transformers.js. And on the left side, I'm going to choose Next.js. Now this library can be used to fetch models in both client side, that is the browser, also server side, that is either in Node.js or Next.js runtime. In this case, our API is going to run on server, and that is going to create these embeddings. So we are interested in server side inference. So I'm going to scroll down to the server side inference. So as you can see, first we'll have to install this npm package, and then we'll have to mention this in our Next.config.js file. This actually specifies the loader as the Onyx runtime. Onyx basically is an open set of standards that allows us to run and train models across platforms. And then finally, we'll be using the pipeline function that comes from the npm package that we'll be installing, and we'll be specifying the task name and the model name, and we'll be able to create embeddings from this. So let me go ahead and do that. I'll just install this Genova Transformers package on our app. Next, I will be copying this next config part and go to the nextconfig.mjs and replace this next config with the copied code. Now back in our utils.ts file, we are going to write const model name, and we are going to copy the model name from the model card. So I'm going to go to model section and then go to feature extraction, and we're choosing the top trending model at this moment. I'm going to copy this and paste it here as model name. Then I'm going to write const extractor is equal to await pipeline, and this is going to come from the package that we installed. And here we are going to specify the task name as feature extraction and the model name. Now it takes some additional parameters. So let me go to the model card again, and I will go to the files and versions. Here, if I go to the Onyx folder, as I said, Onyx is basically the open runtime that allows us to train and run these models in a cross-platform way. And as you can see, it has a quantized version of the model and the full-sized model. And by default, this pipeline function loads the quantized version. Now, in our case, when we are inserting a complete book into a vector database, the processes are expected to run for a few hours. So it makes sense to maybe wait for a few more minutes to load the full model and then generate embeddings using that in the subsequent hours. So in this pipeline function, I'm going to specify quantized as false. So it is going to load the full-sized 1.3 GB model, and we'll be able to use that to generate our embeddings. Now let me go ahead and console log this extractor here. Now if I run my app npm run dev and refresh my app. Now before I click this upload button, let me go ahead and open up the node modules and under the Genova folder. So when I click on this upload button, what it's going to do is that it's going to create a cache folder inside it, and it's going to create a directory with the model name where 1.3 GB sized model will be fetched and stored, and that is going to spin up and create the embeddings for us. So I'm going to go ahead and click on this upload button, and sometimes I have to hit this refresh. So if I go ahead to the same folder, you can see the cache folder has been created, and inside that directory with the model name has been created, and inside that the model file is being populated at this moment. And since it's a larger model, so it is going to take some time depending upon your internet connection. So after that is done, you will be able to see that the model is here. So as you can see that it did get created, and it created a Onyx folder. And if I open this up in Finder, so you can see that within that a Onyx folder was created, and the model file, which is of size 1.3 GB, got created, and this is going to spin up and allow us to create these embeddings for free. So back in our code, we have already instantiated the extractor model. Now we'll go ahead and loop over the documents that we received. So I'm going to write const doc of docs, and I'm going to await. Basically, I want to create another function that processes each of these documents. So I'm going to pass the client, the index name, the namespace, each of those docs, and the extractor instance. I'm going to place my cursor here and press command dot and add that function here. Now, before I start chunking these documents, let me go ahead and console log each of those documents to see what kind of information we are loading here. So we have already created this documents folder. So I pasted two files, one is PDF, another is text. And let me go ahead and press this button. And as you can see that first, this is the console log of the extractor. And this time the extractor was loaded way faster because it did not have to fetch the 1.3 GB model over the internet. It is already using the cached model file. For the documents, we loaded two documents, and each of them has, as you can see, page content, which is basically all the text of the PDF file for the first instance. And it also has some metadata, which includes the source of the PDF file. And for the second content as well, it has page content, and the metadata contains the source of the file. One thing to note is that for the PDF, since we are using different loaders, you can see for PDF, other than the source information, we also have a PDF key, which has some additional metadata as well as the total page count, which is 1884 pages for that PDF file. Now we will be using the page content for each document and create chunks of appropriate lengths, and then create vectors and then push that to the Pinecone database. For creating chunks of appropriate length, we are going to use recursive character text splitter from LangChain. Let me go to the documentation first. So I'm going to search for LangChain.js text splitter. And as you can see, there are a few strategies of creating text chunks: split by character, split code, and markup. So in all of these cases, as you'll see that you'll be using the recursive character text splitter, the character text splitter, or the token text splitter in one way or the other to get the desired result. For example, for code and markup, you will initialize the recursive character text splitter itself to create chunks that preserves the context of code snippets. You can also use the character text splitter itself along with adding some sort of chunk headers in an effort to preserve the context for each of those chunks. So when these chunks show up in a similarity search, then you can add that context information in some way into the final prompt. But that is going to be a topic of a separate video. Here I'm going to use the simple recursively split by character strategy. And as you can see, this is recommended for generic text. It has a default list of separators and it uses them in this order. As you can see, it says it has an effect of trying to keep all the paragraphs and then sentences and then words together as long as possible. That is to say, one paragraph is arguably one coherent piece of text. So it maintains those paragraphs as long as possible. And only if a paragraph is too long, it will split by a new line. And only if there are too many characters between new lines, then it is going to split by space, which is probably never going to be the case unless you specify a very small chunk size. You can also specify the chunk size and the chunk overlap. Do note that the chunk size is the maximum number of characters in a chunk, not the exact number of characters. As you can tell that it will have variable number of characters in a chunk depending upon where the new lines and the paragraphs are appearing in the text. And the chunk overlap is the overlap between two adjacent chunks, which can be used in some way to preserve the context between two chunks. We'll use default values for both of these, which are 1000 and 200 respectively. So back in my code, I'm going to write const splitter is equal to new recursive character text splitter from LangChain. And here you can specify the parameters like chunk size and chunk overlap, but I'm going to keep them at their defaults. Now I'm going to say const document chunks is equal to await splitter dot split text docs, basically doc dot page content. And since it's an async function, I'll have to make the parent function async as well. That's why we had to await the return of this process document function. Here I'm also going to extract the source information from this document. So I'm going to paste a JavaScript function here that basically takes in a long string and then it identifies the last occurrence of the slash and then gets the file name accordingly. And here you can see I'm using this substring to remove the extension of the file like .pdf, .txt, etc. because I'll be using this file name to generate unique IDs for each of those vectors. And if the file is either PDF or text and if it has same name, so then I don't want to create another embedding for the same content. So that is why I'm using this substring to remove the extension of the file. But if you want to preserve that, then you might want to remove this substring. So here I'm going to call the getFileName function to get the file name, and I'm going to pass the doc.metadata.source. Now let me bring down this console log, and I want to console log the length of the document chunks. So I'm going to write document chunks.length, and I'm going to clear the terminal and then go ahead and click on this button again. So basically you can see that we are loading 4600 chunks as part of this document and 3362 chunks for this text document. Now there are two bottlenecks here, or long running processes. One is the generation of the embeddings for all these chunks. Another is upserting of those embeddings into the Pinecone database. So we won't be generating embeddings for all these chunks at once and then push all of them at once to Pinecone. We will be doing that in batches. Now keeping a batch size of 10 worked for me. You can test out larger batch sizes to suit your need. So I'm going to create a config file here at the root of my project, config.ts, and I'm going to export a const batch size is equal to 10, so that to test batch sizes, we can just simply change this variable here. Now back in my code, I'm going to initialize a chunk batch index. This will identify each chunk batch, and this will be used to identify the vector in the end. So I'm going to write a while loop, and as a first step, we are just going to increment this chunk batch index, and then we are going to take one batch out of the document chunks. So I'm going to write chunk batch is equal to document chunks.splice, and this is a destructive function. So I'm going to take out batch size. So that is going to be imported from .config.ts where we defined it. So we are basically taking out 10 elements from these document chunks And when I say destructive function, it is because it reduces these document chunks original array itself. And in the while loop condition, we are going to check if this document chunks dot length is greater than 0. So as long as there is chunks left in the document chunks array, we are going to run this process. Finally, for each batch, I'm going to write another function, await process one batch, and I'm going to pass along the same set of parameters: client, index name, namespace, the extractor, the chunk batch that we just got, the chunk batch index, which will be used to identify each vector, and the file name, which will again be used to identify each vector. So I'm going to place my cursor here and then command dot to add the missing function. So inside it, I'm just going to create the embeddings first. So I'm going to write const output is equal to await extractor, and the parent function has to be an async function. I'm just quickly going to check that I'm awaiting the return type here. And as a first argument, as you can see that it takes a string array, and we have received as our chunk batch a string array of 10. So that is what we are going to pass here. But this chunk batch has strings that are not very clean because this comes directly from the page content. So I'm going to write a map function here that is going to clean each of those strings, and it receives each string, and we are just going to use string dot replace. And here I'm going to mention a regular expression that finds all the new lines and replaces them by space. So in this chunk batch, which is an array of 10 strings, each of the strings will be mapped over, and we'll be finding new line characters, and we'll be finding all of those new line characters and replacing them by space. And that array in turn will be passed on to the extractor as its first argument, and that will generate the embeddings. Now this extractor takes additional parameters. One such parameter we would like to set is the pooling one. Pooling allows us to create embeddings of fixed length for all the chunks. Now, according to the Hugging Face documentation for this model, it supports the CLS or the classification and mean pooling. Now we want to use CLS as this results in embeddings representative of the entire text. It mentions that the CLS is by default, but while generating embeddings using Transformers.js library, I was getting different sized array. So I'm going to have to specifically set the pooling to CLS, and I'm going to do it by passing an additional parameter here, pooling to CLS. Now let me go ahead and console log this output. So I'm going to write console.log output and go ahead and clean this terminal and then hit this button again. As you can see, we started generating the embeddings, and each of those embeddings is a tensor with dimension 10 by 1024. The 1024 because we are talking about a vector in a space of 1024 dimension, and we passed a batch of 10 strings. So we are getting a tensor with the dimension 10 by 1024. Now, as you can see, the size is same for all the tensors, but let me go ahead and remove this pooling, and I'll stop this service by hitting Ctrl C and run it up again, npm run dev. And if I press this button again, as you can see, we are getting different sized embeddings, and that is the reason why I had to set the pooling to CLS. So I'm going to stop the service again. Now this, as you saw, that this output is coming as a tensor. Now to convert it into a JavaScript array, we'll be using the toList function on this. And so I'm going to write const embeddings batch output.toList. And as you can see, it converts the tensor data into an n-dimensional JavaScript list. That is what we want. Now we'll convert this embeddings batch into a vector that will be pushed into Pinecone database. So I'm going to create an array called vector batch. It's going to be of a specific type, Pinecone record. This is just to make sure that the type safety is preserved, and it's going to be a typed one. So record metadata, an array of that, and it's going to be initialized as an empty array first. Now I'll create a for loop where I will go over the batch of these 10 chunks. So I'm going to write for let I is equal to 0, I less than chunk batch dot length I plus plus, and here we'll be extracting the chunk as well as the corresponding embedding. So I'll write const chunk is equal to chunk batch I, and const embedding is equal to embeddings batch, and that will be specified using the same index. So idea is that we'll save the embedding in a vector store in a 1024 dimensional space, and the text chunk will be stored as metadata. So later when we do a similarity search on the vector store and a few embeddings come up as top matches, then we will get the text chunk from the metadata and stuff them into the prompt that is going to go to the LLM. So for each of this chunk and embedding, we're going to create a vector. So we're going to write const vector, and it's going to be of this specific type, because when we will be pushing this vector into the Pinecone using the Pinecone client, this is the type it expects, and it is going to be an object. As you can see, it takes two mandatory parameters, ID and values. For the ID, we are simply going to use the file name and chunk batch index and this index within that chunk batch, append them together to create the unique ID. File name, chunk batch index, and the index within that chunk batch. And for the values, I'm going to specify the embedding itself. And as we said that each of those vectors will also have a metadata, which will basically contain the text chunk that the embedding represents. And finally, we'll push this vector to this vector batch. And when this runs for each chunk batch, that is it runs 10 times, we'll have an array of 10 vectors. So to push that to Pinecone database, we're going to get the index. I'm going to use the client.index function and we'll specify the index name here and then namespace and specify the namespace here. And we're going to await index.upsert and we're going to use the vector batch to push it to the Pinecone. And after that is done, we're going to set the vector batch to be an empty array again. So we're ready to process the next set of batch. Now let's go ahead and test this app. I'm going to run this by npm run dev, refresh my page, and index name I'm going to specify index1 and namespace I'm just going to write test space and click this upload button. So now we'll not be able to see anything here because we are not console logging, but if the process is running properly, then that means that we'll be able to see that in the Pinecone. So if I go to index1, we can see that our vectors are being populated. So as you can see that it is being populated 10 at a time. I'm going to go to the namespaces and as you can see, it created a test space and vectors are being pushed into it. Now, if I check out any vector here, as you can see, it has stored the embeddings in the values field. It has an ID and we have also stored the metadata as chunk along with that embedding. So when we'll be running similarity search onto this vector store, this embedding will be used to find the similarity and then on those top results, we'll be unpacking this text chunk and stuff them into the final prompt to generate the final response from the LLM. Now, all there's left to do is to go ahead and build the progress callback so that we can send back the progress updates back to the client. So we'll do that. So I'll stop the service here. And here when we're receiving this progress callback as function pointer, I'm going to store this as a variable. So I'm going to write let callback is going to be of type, the same type that we specified here. And when we're receiving it, we are just going to save it into this variable that we just defined. I'm also going to create two more parameters, let total document chunks, which is going to be of type number. This is going to store the total number of chunks for each document. And I'm also going to create another one that is total document chunks upserted. That is also going to be of type number. This is going to store how many of those chunks have been uploaded to the Pinecone database. And with each call to this update vector DB, we are going to set these two variables to 0. And right after we have generated the document chunks using the recursive character text splitter, I'm going to set total document chunks is equal to document chunks dot length and total document chunks upserted is equal to 0. And when we are done upserting, we are going to increment the total document chunks upserted plus is equal to vector batch dot length. And after the upsert is done, I'm also going to invoke the callback. So I'm going to first check if callback is not equal to undefined. This is mostly to satisfy TypeScript. Then I'm going to invoke the callback and I'm going to pass the file name, the total document chunks upserted, and for is complete, I'm going to say it's false. And I'm going to do the same thing right after we are done with all the documents. So here we are going over all the documents and then processing each of those documents. So I'm going to do the same thing here, just that here the file name does not matter. Only thing that matters is the is complete is true. So when we'll be invoking this callback, this is basically going to execute this block of code in the API. And when it is not complete, it is just going to write it back to the client using this response.write object. And when it is complete, it is just going to close the response. Now, before I go ahead to the client side code, let me just do one last check here. I'm going to write console.log and I'm just going to print these values on the server itself. So I'm going to write file name, total chunks upserted, and is complete. Now let me go ahead and run this app again, npm run dev. I'll refresh my page. I'll write index1 for index name and test space again. I'll click the upload button and as you can see, it shows the file name and then the total number of chunks that are to be uploaded and the chunks that has been uploaded and is complete is false. So that means that when we write this back and we are writing this back to the client, when we unpack it onto the client side, we'll be able to calculate the progress and show it on the page. Now back in our client side code, we are going to write this process streamed response function. So I'm going to place my cursor here and then command dot and add missing function declaration. And I'm going to bring this function up just below this function call itself. As you can see, it has also detected the type, and it is coming from the MDN reference. So this is the response of the fetch API. So it has detected that type correctly. So before I go ahead and write this function, I'm going to create two state variables here, state snippet, and I'm going to name it file name. That is going to basically store the file name that will be getting the progress of, and another will be the progress itself, and this is going to be of type number. So I'm going to initialize it with a value of 0, and I'm going to bind this to the label file name and the progress bar. So I'm going to go to the file name label, and after this I'm just going to write file name, and for the progress I'm just going to remove this placeholder value that we used earlier, and I'm going to write progress here. And with each call to on start uploading, so whenever we're starting the uploading process, we're going to set the progress to 0, set the file name to an empty string, and we're going to also set is uploading to true, which is going to show the progress bar and the file name container that we have hidden in case of is uploading is false. Now inside this function, we'll first get the reader from the response body. So I'm going to write const reader is equal to response.body.getReader, and we'll check if the reader is available. If it is not, then we are just going to console log an error, reader was not found, and we're just going to return from this. And if the reader is available, then we will continue. So for the reading of the stream response, I'm going to wrap that in a try catch block. I'll come to this error later. For the try, I'm going to read in a indefinite while loop with a break statement inside it. So first I'm going to call the read function on the reader. So I'm going to write const, and the read function returns two values, that is done and value, and it is going to be await reader.read, and that means we'll have to make this parent function an async function, and just checking that we are awaiting the response here as well. Now if I hover over this read function and then go to the MDN reference by command clicking on this, then you can see that it returns two objects as we are unpacking. One is the value, which contains the chunk, and if the chunk is available, the done will be false, and when the stream becomes closed, which we'll be doing when we are calling the response.end function from our API, then the value will be undefined, but the done state will be true. So that is how we'll be able to tell that the process has ended. So we are just simply going to check if done is true, then first we are going to set uploading is uploading to false, and we're going to break out of this while loop, else we'll continue. So we'll unpack the progress here. So if I hover over this value, then you can see that it is uint8 array. So we'll have to use a text decoder to decode this value. So I'm going to write const data is equal to new text decoder, and this is coming from web API, and I'm going to call the decode function on this and pass the value here. Now let me go ahead and console log this data to see what we are getting as part of the streamed response chunks. So I'm going to bring up my service, npm run dev, go to my app, refresh the page, write index1 in place of index name, and test space. I'll open the console and hit the upload button. As you can see, we are getting the JSON object. So whatever we are printing here on the service, the same thing we are getting here, file name and total chunks upserted, and is complete is coming as false. So we're ready to parse this string as a JSON object and then unpack these values and then calculate the progress using that. So I'm going to stop the service here. So first I'm going to use JSON.parse. I'm going to pass the data here. That is going to give us a JSON object, and from there we are going to unpack it to get the file name, total chunks upserted, and is complete. Now I'm going to calculate the current progress. It's going to be chunks upserted divided by the total chunks times 100, and then I'll set progress with the current progress and set file name. Now I could just set the file name here, but I'm just going to also append the raw numbers, that is the total chunks and chunks upserted, along with the file name, so that it shows just beside that. So I'm going to write file name. So along with the file name, I'm also going to show the total chunks and how much of that chunk has been upserted, and below that there will be the progress bar. Now if it is resulting in an error, we are just going to simply console log the error, console.error. We're going to write a message error reading response, and we are console logging the error stack. And finally, as a best practice, I'm just going to add the finally block, and we are going to have to release the lock of the reader function. Now we are ready to test our application. Let's run it by npm run dev. I'm going to refresh my page, index 1 here, and namespace test space. I'm going to hit the upload button, and it is empty now, but it is showing that it is uploading. And after some time, we start with the first file name, and we can see that 20 of them have been pushed out of the 4,600 total chunks, and we can see the progress bar getting filled up. Now we'll show the list of the files here in this box that are to be uploaded. And for that, I'm just going to quickly write another API, and that is going to be a simple get handler. So I'll stop the service here, Control C, and inside this pages/API directory, I'm going to create a new file, get file list.ts. And here I'm going to export default async arrow function, and it is going to take a request instance as usual, next API request, and a response instance, next API response. And we're going to check if the request dot method is equal to get. Here we don't need to load the files and their content. We just need the list of the files. So for that, I'm going to import fs or file system, fs from fs, and then const files is equal to fs.read directory sync. And then I'm just going to specify that same documents folder. And that's going to just give us the list of file names as a JavaScript array. So we are just going to simply write it onto the response, and we can easily do it by writing res.status. That is going to set the status, and we're also going to write the JSON object. So we don't have to use JSON stringify. This stringifies this. So we are going to pass the JavaScript array, which we received from this read directory sync function call. So I'm going to write the files, and that is going to send back the list of files onto the client. Now back into the client side code. In the UI code, we specified that this button will be used to refresh the list of files. So I'm going to write an on-click handler on this, and I'm going to name it on file list refresh. And I'm going to create this function here in top, const on file list refresh. It's going to be an async function, async arrow function. It does not take any parameters, and it's going to send a fetch request, const response is equal to await fetch. And the API is what we specified, get files list. It's actually get file list, and the method is going to be get. And I'm going to unpack the response, const file names is equal to await response.json. I'm going to console log this file names. Now I'll test the app, npm run dev, to spin up the service. I'm going to refresh the page and click on this button, and as you can see, we are getting the file list, and this is coming as a JavaScript array. Now to show it on the page, I could create an unordered list, but I'm going to keep it very simple here. I'm going to simply create a state variable. I'm going to call it file list as text, and it's going to be an empty string in the beginning. And on file list refresh, on each call of this function, I'm going to set file list as text to an empty string. And here I'm going to loop over this file names array. So I'm going to write const result string is equal to file names dot map. So I don't get the map function here, but we know that we are receiving a JavaScript array. So I'm going to typecast it as an array dot map, and it is going to iterate over each of those file name. So basically we are going to append a document icon in front of each of those file name, and I'm not going to use any Lucid React icon here. So I'm going to just search for Unicode character for page, and here I'm going to search for page, and I think I'm going to go with this Unicode character. I'm just going to copy this, paste it here, and then write file name. After I modified each of those file name like this, I'm going to join them using a new line character. That is how I'm going to create the result string, and this result string is what I'm going to set as the set file list as text. Finally, I'm going to bind this value to the text area. So I'm going to write value is equal to file list as text. If you save it, go back to our page and refresh it. If we click this button, we can see that the file list gets populated. And now if we write index1 and test space or any other space, let's use test space 2 for example. If I click this upload button, you can see that it starts with the first file, and there are 4,600 chunks to be uploaded, and right now it is 50, and then 60 chunks have been uploaded. Now if we go to the Pinecone console, we can see that there is another namespace that got created, test space 2, which is specified, and chunks are being uploaded 10 at a time. So that completes this app where we'll be able to upload documents onto our Pinecone database and build the knowledge base. In the next app, we are going to utilize this knowledge base to answer specific questions about medical reports of a patient. So thank you for watching. See you next time.